All right, number 11. We have x equal to 2y plus 5 and y equal to 2x minus 3 times x plus 9. How many order pairs x comma y satisfy the system of equations shown above? Okay, so this is a system of equations question, but this one is not a system of two linear equation. Because second equation here, this is a quadratic because we do 2x times x, that's like 2x squared, right? So it's a quadratic equation. So if we're gonna do it algebraically here, okay, we could begin with a substitution here. Right, since we have x equal to 2y plus 5, we could plug in 2y plus 5 here for x. Okay, so for x's, we can do a substitution there. So this should give us y equal to 2x, right? So instead of 2x, we're gonna say that 2 times 2y plus 5 minus 3. Second parentheses is x plus 9, so that would be 2y plus 5 plus 9. Okay, so you do a substitution, and then we can clean things up a little bit. So this should be the 2 here. So the first one should get 4y plus 10 minus 3. And then here is 2y plus 5 plus 9. And then combine the numbers here, we get 4y plus 10 minus 3 is plus 7. The second one, 2y plus 5 plus 9 is plus 14, like that. All right, so now this is the equation that we're working with. Okay, and we want to figure out how many solutions we have. Okay, so what we could do is from here, since it's a quadratic equation, we do have to set it equal to 0. Okay, and then we can solve for y here. It's a little bit weird, usually we're solving for x, but we can use the same method here. So since this equation is all with y, right, we can still solve for y here. But since it's quadratic, we do have to set it equal to 0 first. Okay, so we can do on the right side, we can multiply this out. So this will be FOIL. So 4y times 2y is 8y squared. Plus the outside term, right? The other term is 14 times 4. That should be 56. Okay, 56y. Plus the inner term, 7 times 2y is 14y. Plus last term times last term is 7 times 14 is 98. Okay, yep. And then we can do combine like terms. 8y squared plus 56 plus 14 is what is 70y. Okay, plus 98. All right, and then we can do subtract y on both sides, set it equal to 0. Okay, then we get 8y squared plus 69y plus 98. Okay, so that's the equation that we have after we multiply things out and simplify. Okay. So usually we have quadratic equation from here, we'll factor it, right? And then we try to solve, set each factor equals 0 and solve from there. But then this will be pretty difficult to factor. It might be factorable, but it will be rather difficult. Okay, and then since this question, we just want to know how many solutions we get, right? It doesn't matter what is exactly the solution. Okay, we just want to know how many solutions we have. So here, what we can do is we can use the concept of determinant. Okay, we can use the determinant. And what is the determinant? That's the part under the square root in the quadratic formula. So remember, quadratic formula is negative b plus minus square root of b squared minus 4ac all over 2a. Okay, so this part under the radical, the b squared minus 4ac, that's called the determinant. And this help us, this can tell us how many solutions we have. Okay, so we take the b squared minus 4ac. So what happens is if b squared minus 4ac is greater than 0, then we get two real solutions. Okay, b squared minus 4ac greater than 0, we get two real solutions. And b squared minus 4ac is equal to 0, we get one real solution. And b squared minus 4ac is less than 0, we get no real solution. Okay, and that will get two imaginary solutions, but no real solution. Okay, since for this one we can check, right? So we can plug it in. B squared minus 4ac. So you can solve for a determinant. That should be, the b value is 69, 69 squared, minus 4 times a is 8, c is 98. And we recognize this, that this is a no calculator session, but 69 squared should be a fairly big number. Okay, so it should be pretty big. Okay, so we think about like 50 squared will be 2,500, right? So 69 squared will be even bigger, and then it's actually a lot bigger. So if we multiply, and I just verified this real quick. Okay, so if you multiply this out, 69 squared is 69 times 69, and 9 times 9 is 1. Right, and then 981 carry a 8, 6 and 9 is 54, plus 8 is 62. Okay, and then bring a 0, 6 and 9 is 54, carry a 5, 6 and 6 is 36, plus 5 is 41. Okay, we should get 4761. Okay, that's 69 squared. Okay, 4761 minus, so all we want to check is if this number is bigger or smaller than 4761. Okay, so 4 times 8 is 32 times 98. 32 times 98. So unfortunately, we have to multiply this out. Would be 16 carry a 1, 3 times 8 plus 1, 25. And then 2 times 9 is 18 carry a 1, 3 times 9, 27 plus 1, 28. Okay, we add them up. 6, 13. And then the 11, 3. Yeah. So it'd be 3, 1, 3, 6. Okay, for this one here. So you see, this is smaller. Right. So we have a bigger number minus a smaller number. We should get a positive answer. Okay, so it's definitely positive. So determinant is positive. We know we should have two solutions. Right. So letter C will be our answer here. Okay. So obviously this is a lot of work, right? So we multiply out as multiplication and no calculator. So it's very time consuming to do it like this. So this is the way to do it algebraically. Another approach to this, okay, which I think is definitely easier, but it's more difficult to see. We could also do this question graphically. Okay. We can do it graphically. So what we can do is recognize the second equation is a quadratic. And then what we can do is, since it's already in the factor form, we can set each factor equal to 0 and solve for x. And that will be the x-intercept. Okay, so if we solve for x, we should get 2x minus 3 equals 0. We get x equal to 3 over 2. Right, that's a 1 x-intercept. So these graph, it doesn't have to be perfect. Okay, so let's just say that 3 over 2 right there. And then we do x plus 9 equals 0, x equals negative 9. And that's another x-intercept at negative 9. Okay. And then the parabola should open upward because there's a positive a value in front. Okay, so it's a parabola opening up. So the graph should look something like this. Okay, and if you think about this, the other equation is a linear equation. If you get it into the slope-intercept form, we solve for y, we can do minus 5 on both sides. Right, x minus 5 equal to 2y, and solve for y divided by 2. We should get y equal to x over 2 minus 5 over 2. Okay, so we should have a negative 5 over 2. It's a y-intercept, and then slope is up 1 over 2. Right, so it should go something like this. Oops. Right, it should go something like this. Right, and we could verify the y-intercept for the quadratic equation just to make sure. If you plug in 0 for the second equation, we get negative 3 times 9, right? So this point should be negative 27. So it's definitely lower than the y-intercept for a linear equation. Okay, so you see we draw it like this. Right, the graph is not 100% accurate, but we see that it should go through the two graphs intersect at 2 points. Right, so we should have two solutions here. Okay, so that's is a lot faster, right, if you do it graphically. Okay, so 11, either way, we should get C as our final answer. And, we can at least eliminate, we should eliminate D because we have a linear equation and the quadratic. We won't be able to get infinitely many solutions because they won't be 100% overlapping. Okay, so we can at least eliminate D for sure. All right, so that's it for this question.